right, so the last section is about curve sketching, and this will kind of put all the limit ideas together on a graph. So depending on how many criteria are given, depends on how similar your answers will be. More criteria means almost identical answers. We don't want you to spend any time writing these functions. We just want you to sketch the scenarios that are being requested. Okay? So let's look at our first example. So on this, we want to sketch a function that has three different criteria. So I'm going to talk about each and then what you should be looking for on the graph. Okay, so the first limit wants the limit as x approaches 4. So remember, 4 is your target. They want your function value to equal 2. So remember, that is your y value. Okay, so in order for a limit value to be equal to 2, remember, we needed either a filled in circle or an open circle, okay? And since it's at x equals 4 and y equals 2, you want that whole or filled in circle to be at 4, 2. We don't know yet. So what I do is I kind of go down to 4, 2, and I just say like, well, I know if it's a limit that it has to agree from both sides, but I don't really know much other information yet, okay? Our second criteria says f of 4 is undefined. So what that means is that there's no y value when x equals 4. And if we leave that as an open circle like I've drawn, then that would be undefined. Okay, so that means we can't have a point off of it. And then the limit as x approaches negative infinity. So remember, x going to negative infinity, those are the left x values on your graph. So we're looking at the far left. We want those y values to be going towards -1. It could be an asymptote towards -1. It can be -1 exactly. We don't really know. So we need to make sure, and I go over here to the left, and I go to -1, and I say, you know what? We need to be rounding out about here, okay? So now that's just a rough sketch of the criteria that needs to be met. So what we need to do, though, is we need to create a function from the left and right of our graph that has those three features included. So what I want to do is I want to connect these so there's not a big hole there. Then I want this to keep going, and it can do whatever it wants because we don't have any limitations on the right side of our graph. And so if this was my final graph, it would meet all three criteria. Okay? So let's do a different one. So let's look at example 2. So this one only has 2 criteria. So I want the limit as x approaches 3. Remember, that's an x value. We want that to not exist. So what does it mean not to exist? It means that the left and the right can't meet. You have 2 options. It can be asymptotes going different directions, or they can be completely just separate parts of a graph. They don't have to be an asymptote, okay? And so we know that's at 3. Okay, so I'm going to keep that in mind, but I'm not ready to draw anything on my graph yet. Let's go to our second criteria. So our second criteria is a function value. And so that means we need to have a filled in circle at 3, 2. So that's going to kind of get rid of the idea of our asymptotes going to infinity, since I have a function value that's being needed. Well, I can put that in. So if we've got 3, 2, I'm going to make sure I have a filled in dot. And then I'm going to go back to our first criteria. Since it can't be an asymptote, we're going to have just our limits going to different directions. So I can make this one go up, and then my second part of the graph to the left needs to start at x equals 3, but it can't meet up with there. So I'm just going to come down to here, draw an open circle. I'm just going to make this one straight. Sure, well, I said straight, but it doesn't really matter, okay? So that means my limit wouldn't exist, and I have the function value, okay? So I have a bunch of criteria for you to try on your examples, and just make sure that they're met, and then your graph doesn't have big gaps in the x values that are being represented, okay? And then it should be pretty clear.